Right, I'm here to talk to you today about Extruder, which is a little utility that allows you to populate Scala case classes from any data source. But first, a little bit about me. My name's Chris Jansen, which you probably already know. I'm a senior consultant software engineer here at QuantumBlack. Well, I may be a consultant, but I don't get out much. So this is my first time talking at one of these kind of events, so go easy on me, please. I've been a Scala developer for about 3 years. Before that, doing stuff like Ruby and Java. So far, enjoying it. I've been kind of fully absorbed into the functional programming kind of cast, I suppose. I'm a bit of a type level fanboy, so I'll talk a little bit about monads and stuff today, but I won't go into details because I don't understand them anyway. Let's talk about Extruder. What is Extruder? Probably best I talk about what extrusion is first. It's a kind of manufacturing process that involves a blank piece of raw material, a die, heat, and then a final product pops out or is extruded out the other end. So to make an analogy for Scala, the blank is a data source, heat is what's produced by the Scala compiler, die is types, and then the final product is a passed instance of a type. So what is Extruder specifically? As I said, allows you to populate Scala case classes from any data source, or indeed any type, provided there's a decoder or encoder available. We'll cover that a little bit more later on. It uses type class induction to derive decoders and encoders. I'm probably not going to go into loads of detail here about what this is. I've got some references at the end with a really good talk by Aaron Levin from SoundCloud, I think, about this. It's pretty good, but I'm not going to go into loads of detail. And it's built with shapeless and cats from type level, thus my fanboyism. Bit more about what it's about. It's part of the type level incubator, got accepted back in March, along with 2 other projects that are very similar. Pure config that just passes type safe config, if anybody's used that before, and case classy from 47 degrees, which is very similar to Extruder with a couple of key differences that I'll pick up later. So usage, what might you use Extruder for? Well, configuration parsing is one. You start up an application, you might want to load some config from somewhere, say type safe config, system properties, environment variables, a database, wherever. And then you might use that with dependency injection. There's something like MacWire or Grafter, if anybody's used those. Or you might want to use it with serialization, so serializing a case class to some sort of data store and then deserializing it. I should stress, though, that I'm not attempting to make some sort of ORM. I wouldn't use it for that. But anyway, you can use it for kind of blocks of data. And more specifically here, we've used it for loading and saving Spark data frames. So you can have a Spark job as say a case class, and then data loaded and saved from that. So what are the differences between this and the existing projects? So pluggable backends. Pure config just deals with type safe config, which is really useful if most of your config is in type safe config. But if you want to load from somewhere that isn't that, then you need something else, maybe case classy, maybe this. It's got a configurable result type. So this can be something like, it's essentially the monad that you get back that encapsulates the error path. So if there's been some sort of validation failure, then then you can have that represented in whatever type you want, say a try, an either. The default is validated from cats, if anybody's used that before. And a separation of side effects. So by default, side effects aren't separated. So if you're reading from a database, then that will be lifted into the normal target result type. However, there's an option where you can split these out into something, into a different type. And I'll cover that more later on. So why did I do this to myself? Well, I wanted to try out generic programming with Shapeless and give it a bit of a go. I wanted to learn a bit more about cats. And I wanted to remake the wheel, because, you know, it's always fun. So that's it, really. So moving on. Decoding. So into a bit of the meat of it now. What do we mean by decoding in this instance? I mean reading from a data source and then fitting that into a certain type. Well, maybe fitting it into a certain type depending on whether it passes. So you could go from a map to a Scala case class. You could go from environment variables to, say, an integer. It just depends on whether there's an implicit instance of a decoder for the type that you want in scope. So supported types. Extruder gives you a few things out of the box. So primitive types. Notice my emoji pairing here. I'm very proud of this. Especially this one. I won't read them all out. But it also, as well as these primitives, it supports kind of other things like options. You can say that something's optional, and then you don't have to include it in your config. Any traversable wants collections, so sequence, list, set, etc., etc. Scala case classes, and sealed type members. So where you've got a sealed trait and you've extended it a number of times, you can specify a type discriminator in order to instantiate a certain type. So let's have a little demo. What I'm going to do is go from a Scala map with valid data, and we'll see it populate a case class. And then we'll go from invalid data and see what errors we get. And we'll also display the parameters. There's a way of printing out in a nice table what parameters may or may not be required with defaults. So what we've got here is, I'll just put an example in Scasty, so after this anybody can go and have a look. But I've got a case class called application config. It has a number of parameters. The first one is defaulted, it's an integer. We've also got an optional double, string, and a set of integers. So in my valid config, all I have to provide is the values for the things that either aren't defaulted or optional. And so notice that the keys are namespaced by the name of the case class. Everything's lowercase and dot separated. And then invalid, what I've done is not provided values for these, and instead provided a value for number, which isn't a number. So we can see that what we get back is a validated application config for the validated, or the valid config, and an invalid non-empty list of failures. So something saying that it's not a number, the fact that two values are missing. And also we print out a list of the parameters, the expected keys, whether or not they're required, their types, and whether they're defaulted. So that's decoding. What about encoding? So if decoding is reading from data source, encoding is writing back to this data source in a certain format. So you might go from a case class to a map, but you wouldn't necessarily, and I haven't done this, go back from, say, an integer to environment variables. Partly because I don't think it's particularly sensible, especially if you've, say, got a huge kind of case class hierarchy. It could make a mess of your environment. But there's nothing stopping someone from coming along and writing a data source that does do that. And as with decoding, this works as long as there's an implicit encoder in scope. So let's have a demo of encoding. This time we'll go to a Scala map from a case class, but then we'll go back and check that it's equivalent to the original. So here's another SCSD snippet. It's the same case class, but this time we'll provide an instance of it. We encode, then decode, and check equivalence here. I'm also printing out an encoded value, just so that we can see what it looks like. So here we go, we've got the valid map with all of the values, namespaced, encoded, and then the check that the decoded case class is equivalent to the original case class. So it works, nice. So that's encoding. What about data sources? I've talked a bit about these already, but this is where data is loaded from. But essentially, they're just a set of decoders and encoders for a certain source type. So the source type could be environment variables, system properties, database table, you name it. As long as you can load data from it, you can implement a data source. Validation errors are handled by monad error, which is an abstraction in cats. I'm not going to go into loads of detail here. We can whisper monads to each other over a pint later if anybody wants to. But also side effects are modeled by the IO monad internally. You can choose to separate them out. I'll cover that a bit later. But I'm using a concrete implementation of a side effecting, well, something that models side effects. And also traits are provided for creating primitive and derived decoders and encoders. So you don't have to use these if you're making a data source, but they help. So go and check out the source code if you're interested to see how they're used. A bit more about reading and writing data. So internally in a decoder, you have the option to be able to convert to or from an intermediate type. So this could be, say, from a database table to a Scala map. This saves you going and looking up every time you need to look up a key from making a call out to the database, which could be quite slow. You can preload all of the data that you need into a Scala map and then continue. And then encoding uses a monoid to collect all the data. So you need an instance of a monoid to do the collection, i.e. the summation of everything. So if that was a map, you'd have a monoid instance for a map and it would collect everything up. And then that gets flushed out either to a database table or whatever your final type is. So an example of an intermediate type, I've used one here for the type safe config implementation, where it's a map where the key is string, and I've created this type alias called config types, which uses the shapeless code product syntax. So you can say, well, it's either going to be a string, a type safe config value, etc., 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 and then that on finalization, that gets converted into type safe config, and that's what you get back. So changing the result type. What do I mean by this? It's the target type which wraps the result. So the thing that provides you error handling, it represents errors somehow. And it's, as mentioned earlier, it's an instance of monad error. And side effects are modeled by the IO monad. So how do we, well, why might you want to do this? Well, you hate my default. I like it, but you hate it. That's fine. Because you might be wanting to use it in a for comprehension with other things, say like a future. That's great. You can just specify in the type parameters for the decode method. I wanted this in a future, and there you go. Or you want to separate side effects. So side effects being going over the wire to read from a database, You might want to say, actually, I want that represented separately to any validation failures that I get, say converting a string to an integer. So how do we achieve this? With a number of methods that are provided on every data source. The default is decode or encode, which you have this monad, or the thing representing error or success, wrapping the type that you want to get back. There's unsafe, which I don't recommend that you use in production, which throws errors. So you get the type that you want back, but any problems, any side effects, validation errors result in an exception. I/O, what you get back is I/O wrapping the target, the validation monad, which wraps your result type. So this is separating out the side effects. And then finally, async, which allows you to specify something like a future or say a Monix task, which can then wrap your result type. So let's have a bit of a demo. What I've done here is provided a little example of, well, if it's going to let me see. There we go. Scroll down. What I've done is provided a couple of examples of decode where I've specified a type alias called either throwable, which is an either where there's a throwable on the left-hand side, and then the right-hand side is the type that you want. And then I've got it to pass an invalid config. So here you go, you see that we have the left-hand side of the either with an exception in it. The same can be true for future. Oh yeah, notice here that I also have to specify the error type separately. That's a monad error thing. So here we go, I can say future, which means that all of the side effects and all the validation errors are represented in a future. Unsafe, I've had to wrap that in a try so that it doesn't blow up my whole example. You see you get an exception back. I/O is similar, so you get an I/O monad wrapping validation, which wraps the expected type. And then finally, here's a future which wraps validation, or a future which wraps an either. So you can pretty much, provided you have the right instances and scope, you can say, I want any return type, and then match it up with the types that you're expecting in your application. So that's the changing the result type. How about configuration? By configuration, I mean configuration of Extruder itself. So what can you configure? You might want to change the key format. So we saw in the examples that the map data source expects keys all being lowercase and separated by dots. You might want to change this. That's fine. Or you might want to change the timeout. So for the default encoding or decoding, any asynchronous operation is lifted into the normal validation type, but that means that it has to be, for the most part, evaluated synchronously. So there's a timeout. You might want to change the collection delimiter. So by default, it's commas, but you might want to change it to something else. So how do we do this? With hints. So what do I mean by hints? It's essentially just a class. Oh. Unfortunately, my examples disappeared. However, I can put it up later. But essentially, it's just a class where you can provide an implicit instance in scope and override methods or values which allow you to change the functionality. Anyway. So extending. So why might you want to extend Extruder or the encoding or decoding process? Maybe it doesn't provide you with an encoder or decoder for the type that you want. Say you've got a POJO or a complex type that it can't work out with generic derivation. You can add new decoders or encoders for that data source. But that only works for a specific data source. So say you're going from a database that's typed, you can provide a fairly high level implementation for that. But you can go a bit lower and create parsers for all data sources. So parser is essentially a type class that assumes you're taking in a string and will parse it into whatever type that you want. I can talk more later about those if people are interested. So what are the plans for the future with this? Faster compile times. At the moment, compile times are pretty slow. If anyone saw Travis Brown's talk on generic derivation in Scala World last year, he did a quite good thing on Cersei about generic derivation and speeding that up with macros. Probably steal some of his ideas there. Support more data sources, so things that will exercise the side effecting functionality in Extruder, so maybe one for Redis, HashiCorp Vault, JDBC maybe, all of those. Support for more types like squants. So if anybody's ever heard of squants, it's a library from type level that has types for scientific measures. I already support refined types, so being able to say whether or not, say, an integer's positive or negative, that's already in there, so it will just be a case of following the same pattern to add this. So that's it. I've included references at the end for anybody who's interested. My slides are up here. The GitHub's here. My Twitter's there if anyone's interested in what I don't have to say. Thanks for listening.